All right, today we're going to be talking about polygons and their angle measures. Our objectives for today, we will be able to classify polygons and find interior and exterior angle measures. We also will be able to find the number of sides of a regular polygon given the measures of interior or exterior angles of that polygon. So, first let's talk about what a polygon is. Which of the following figures are polygons? Well, to answer this, we need to know what a polygon is. A polygon is a closed figure It is formed by 3 or more line segments meaning it can't have any curves. The line segments are called the sides. And each endpoint of the sides is a vertex. So what it means by a closed figure is that there's no openings. So this fifth figure here, see how it's open on this side? That means it's an open figure, not a closed figure. So that can't be a polygon. Formed by 3 or more line segments, meaning it has no curves. So this second one can't be a polygon because it's curved edge. The other 3, however, have 3 or more line segments, there's no curves, and they are completely closed. So these 3 are polygons. Now within polygons, there's 2 different types. We could either have a convex polygon or a concave polygon. A convex polygon means no line containing a side contains an interior point. Basically, it means that none of the endpoints are inside the figure. So these are all outside. If we extended the lines, we'd never end up inside of our figure. A concave polygon means it is a figure with at least one vertex in the interior of the polygon. So see how this one sort of goes up into the figure. This one has these vertices inside the shape, whereas in these others, the vertices are all on the outside. Next, we want to draw the diagonals of each polygon below from one vertex only. Then determine the number of triangles created in each polygon. To do this, we must know what a diagonal is. A diagonal is a segment joining two non-consecutive, non meaning not, consecutive meaning next to each other, segment joining two non-consecutive vertices. So if I wanted to draw the diagonal through this shape right here, I'm going to choose this vertex. I can't go to that vertex because they're consecutive. That's a side. Can't go to this vertex because that's also a side. They're consecutive. If I go to this vertex, I skipped one on the way. So that's my diagonal. From this vertex, I can't draw any other diagonals. So that means I have 1, 2 triangles in this figure. In our next figure, I'm going to start here. I can't go to this vertex because that's a side. I can go to that vertex. I can go to that vertex. And I can't go to that one because it's consecutive. So this time I have 1, 2, 3 triangles. In our next figure, I'm going to start here. Can't go to that one because it's a side again. I can go across to here, across to here, across to here, and then I'm back to a side. So now I have 1, 2, 3, 4 triangles. Do you think you can guess how many triangles we're going to have in the last figure? Let's check. If I start here, I can't go to that one, but I can go to one, and another one, and another one, and this one, and then I can't connect to that one. So I have 1, 2, 3, 4, 5. So next, we're going to classify polygons by their sides. So let's start with a polygon with 3 sides. What do we call a polygon with 3 sides? You should know this from our last unit. It's a triangle. Within a triangle, how many triangles are there? There's just one. And what was the sum of the interior angles of a triangle? That's right, it was 180 degrees. We can use that idea to help us determine how many degrees are in these other types of polygons. So if there's 4 sides, it's called a quadrilateral. Let's look back on our figure that had 4 sides, this one right here. How many triangles did we get when we drew the diagonals? There was 2. So if one triangle has 180 degrees, 2 triangles would have 360 degrees. If a polygon has 5 sides, that's called a pentagon. Let's look back at our 5-sided figure. 1, 2, 3, 4, 5. That one had 3 triangles in it. So if we have 3 triangles, what's the sum of our interior angles? It's going to be 540 degrees. A six-sided figure is a hexagon. Our six-sided figure, 1, 2, 3, 4, 5, 6, had 4 triangles within it. 4 triangles times 180 degrees each means we're going to have 720 degrees inside our hexagon. Our 7-sided figure is a heptagon. We had 1, 2, 3, 4, 5, 6, 7 sides here and ended up with 5 triangles. Five times 180 is 900 degrees. So are you noticing a pattern between the number of sides and the number of triangles? Number of sides, number of triangles. Number of sides, number of triangles. That's right. It's always 2 less. So however many sides we have, say we have n sides, our number of triangles would be n minus 2. Whatever the number of sides is, minus 2 is how many triangles we're going to have. So an 8-sided figure is an octagon. Since it has 8 sides, it will have 2 less triangles. So it will have 6 triangles. 6 triangles times 180 degrees is 1080 degrees. A 9-sided figure is a nonagon. Since it had 9 sides, it'll have 2 less triangles, so it will have 7. 7 triangles times 180 degrees each is 1260 degrees. 10-sided figure is a decagon. If it's got 10 sides, 2 less would mean 8 triangles. 8 times 180 degrees is 1440 degrees. An 11-sided figure could be referred to as either a hendecagon, or sometimes it's called an undecagon. If it's got 11 sides, it's got 9 triangles. 9 times 180 is 1620. And 12-sided figure is a dodecagon. 12 sides means 10 triangles. 10 times 180 is 1800 degrees. When we don't know the number of sides, it's called an n-gon. We said it will always have 2 less triangles than it does the number of sides. And we always took the number of triangles and multiplied it with 180 degrees. So something to notice, the n-gon is a generic way of classifying n-sided figures. If you have a polygon bigger than 12 sides, we would refer to it as, for example, a polygon with 14 sides is a 14-gon. If it was a polygon with 72 sides, it would be a 72-gon. We just plug in the number once we get higher than 12. So let's use this idea here. this final set. This idea is going to help us a lot. So, if we want to know the value of x in these two polygons, we're going to need to use the polygon interior angle theorem. So, which tells us the sum of the interior angles of a polygon is always equal to the number of sides minus 2 times 180 degrees. And just remember that n stands for the number of sides. This is a very important formula. We're going to use that a lot today. So in this figure, we have 1, 2, 3, 4, 5 sides. So we know if we have 5 sides minus 2 times 180, that's going to equal whatever we get when we add all these together. Now make sure you're careful and don't leave any of them out. So 5x, and I'm going to put a dot next to each one so I know when I've used it, plus 2x plus 5x plus 90 plus 90. So let's simplify. 5 minus 2 would be 3. 3 times 180 is 540 equals 5x plus 2x plus 5x would be 12x plus 90 plus 90 is 180. Subtract 180 from both sides. I get that 360 equals 12x. Divide both sides by 12, and I get that x equals 30. Next, we have a 1, 2, 3, 4-sided figure, a quadrilateral. So we know that we're going to have to add all these together. Now, when you're dealing with multiples of these and you're going to have lots of like terms, I think it's easiest to line them up. So, such as 2x plus 1, 3x minus 2, x plus 4, and x. 2x plus 3x plus x would be 7x. 1 minus 2 is negative 1, plus 4 is 3. And we know that that equals 4 minus 2 times 180. So 7x plus 3 equals 4 minus 2 is 2. 2 times 180 is 360. To solve, we're going to subtract 3. Divide by 7. And we get that x equals 51. What if we were given the sum of the interior angles and we wanted to work backwards from the sides? So we're going to use our formula. Our formula tells us it's the number of sides minus 2 times 180 will equal the sum of our interiors, which in this case we're given is 1,440. To solve this, we're going to divide by 180. So now we know n minus 2 is equal to 8. Add 2 to the other side. We now know that this figure has 10 sides. What was the figure with 10 sides called? That's called a decagon. Let's look at different types of polygons that we can have. Polygons can be equilateral, which we talked about a little bit when we talked about triangles. Equilateral means all the sides are congruent. So this side is the same as this side, which is the same as this side, which is the same as this side. Equiangular means all angles are congruent. So this one's the same as this one, which is the same as this one, which is the same as this one. Regular polygons are a combination of equilateral and equiangular. All sides and all angles are congruent. So this side, this side, this side, this side, this angle, this angle, this angle, and this angle. They're all congruent to each other. So if we knew the sum of a figure's angles and we knew it was regular, we could then figure out how much each angle would be worth. So find the sum of the measures of the interior angles of the indicated regular polygon, then find the measure of one interior angle. So using our sum of the interiors formula, a heptagon, remember, has 7 sides. Minus 2 times 180 tells us that there are 900 degrees inside of our heptagon. So that's the sum of the interiors. If we want to know just one angle, we would take our sum and divide it by 7 because there's 7 sides or 7 angles, and tells us there's 128.6 degrees in each interior angle. Now, let's switch gears from interior angles and start looking at the exterior angles. In this triangle, we have an exterior angle here, here, and here. Since the exterior angle forms a line with the interior angle, we know that they have to add up to 180. Since this interior is 60, we know the exterior is 120 degrees. Since this interior is 70, we know the exterior is 110 degrees. And since this interior is 50, we know the exterior has to be 130. Well, what's the sum of these exterior angles? 130 and 120 and 110 adds up to 360 degrees. let's look at another one. Again, the interiors with their exteriors going off of them form lines. So they have to add up to 180 degrees. So if the interior is 92, the exterior is 88. If the interior is 87, the exterior is 93. If the interior is 90, the exterior is also 90. And if the interior is 91, the exterior is 89. Let's find the sum of these exterior angles. 88 plus 93 plus 90 plus 89. Once again, adds up to 360 degrees. The examples above show the polygon exterior angles theorem. If 3 exterior angles added up to 360 and 4 exterior angles added up to 360, no matter what the polygon is, the exterior angles are going to add up to 360 degrees. So the sum of the exterior angles of a convex polygon, has to be convex, is always 360 degrees. So if we've got this polygon that has these exterior angles, we know that if we add them all together, it has to add up to 360 degrees. We don't even need to count how many sides there are or how many angles there are, because no matter what, it's going to be 360. So I'm going to line them up so I can add them up. 3x plus 2, 3x minus 5, 2x plus 3, 4x plus 10, x minus 10, 2x plus 60. Two minus 5 is negative 3, plus 3 is 0, plus 10 is 10, minus 10 is 0, plus 60 is 60. 3, 6, 7, 8, 12, 13, 14, 15 x's. We know it has to equal 360 degrees. Subtract 60, 15x equals 300. Divide both sides by 15, and we get that x equals 20. Find the measure of an exterior angle and an interior angle of a regular hexagon. So remember, hexagon means 6 sides. I'm going to start with the exterior angles because I think those are easier since they always are 360 degrees. So since it's 360 degrees for the exterior angle, we're going to have 6 of them. We know that the exterior angle would be 60 degrees. Now, like we talked about on the quadrilateral and the triangle, on here, we knew the exterior and the interior always formed a line. So an exterior plus an interior always has to equal 180. So if my exterior is 60, my interior angle plus my exterior has to equal 180. So my interior angle would have to be 120 degrees. What if we know one interior angle and we want to work backwards to find how many sides it had? So the sum of the interiors, the total of them, we know is n minus 2 times 180. That gives us the total. If we wanted to find just one of them, we would have to divide by the number of sides. We know that that whole formula comes out to be 150 in this situation. So let's solve that. In order to get rid of the n on the bottom, we're going to multiply both sides by n. These will cancel out. We'll be left with n minus 2 times 180 equals 150n. Distribute the 180, get 180n minus 360 equals 150n. Subtract 180n, so all our n's are together on one side. Negative 360 equals negative 30n. And then finally divide both sides by negative 30. And we get that the number of sides is 12. It has 12 sides. For your summary, go ahead and compare and contrast how the interior and exterior angles of a polygon are related. We'll see you in class.